Welcome back to Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to discuss what is scientific notation, and then we're going to talk about how we take a number, such as this one right here, and convert it into scientific notation. And then we'll briefly talk about the reverse process where we have a number already in scientific notation, and then we're going to go back to the original number. Okay? So what is scientific notation? Scientific notation is a way that makes it convenient to express normally really big numbers or really small numbers. Okay, and scientific notation looks something like this right here. I have this number written as 5.68760 times 10 to the second power. Okay, another example would be over here on the right side. We have 7.72 times 10 to the minus sixth power. These two numbers are written in scientific notation. And so what you'll notice in each case out in front, there's a number. Okay, it can be a whole number or it can be a number with decimal points. It doesn't matter. This number has to be between 1 and 9. Okay, so it could be an even 1, an even 2, or it could be 5 point something like this. Okay, and that number is always multiplied by 10 to some power, and it can be any power. Over here on the left side, we're going to look at an example where the power is positive, it's greater than 0. Over here on the right, we'll look at one where it's negative. All right? So let's talk about how we convert a number like this into its corresponding scientific notation. Our number is 568.760. Now, in any example, when we're converting to scientific notation, what we're always going to do is we're always going to move the decimal point either to the left or to the right so that the decimal point is right after the very first non-zero number. Okay? In this number right here, what is the first non-zero number? Well, it's the 5, right? If we look over here on the right side, what is the first non-zero number? It's a 7. So in these examples, we're going to start by moving over the decimal point over to right before that first non-zero number. We have to pay attention to whether or not we're moving the decimal point to the left or to the right. So let's imagine moving this decimal point over. So we have one place over, and then we're going to move it a second place. So I only have to move it 2 spots to the left to get it right after this 5. And if you imagine the number that I would get when I move it over 2 spots, it would be 5.68760, right? All the numbers are still there. The decimal point is just moved after the 5. Now, how many places did I move it to the left? I moved it over 2 places. And so because I moved it 2 places to the left, now I have to multiply this 5.68760 times 10 to the 2 power. And that 2 power comes from the fact that I moved this decimal point 2 places to the left. All right. Now, the question is, how do you memorize whether it's to the left or right? Well, you probably should just memorize it, but also go back and make sure your answer makes sense. Okay. We're multiplying this 5.68760 times 10 to the second power, or 10 to the 2 power. This is 100. Right? 10 to the second power is 100. If we had 10 to the third, it would be 1,000, and so forth. So just take this number right here, 5.68760, multiply by 100, and you should get back to the original number. Okay? So hopefully that makes sense. Now the example we just did, this is a number that's far bigger than 1. Okay? And that's one example where scientific notation is useful. But the other example where it's useful is when the number is far less than 1. In other words, we have 0 point something, so a decimal less than 1. So our number is 0.00000500772. Okay? We want to convert this to scientific notation, and we're going to do the same thing first. We're going to move that decimal point over to right after the first non-zero number, which is this first 7. But I'm going to have to move it to the right this time. So I move it over 1, 2, 3, 4, 5, and 6. So if I move the decimal point right here, I should now have a 7.72. Okay? And then that 7.72 will have to be multiplied by 10 to the minus sixth. Now, the 6 is there because I moved it over 6 places. But the reason it's negative is because I moved that decimal point to the right. And think about it, why that makes sense. If you just punch 10 to the minus sixth power into your calculator, you're going to get a really tiny decimal. Okay? And so if you imagine multiplying that tiny decimal times 7.72, you're going to get something that looks like this, something that's a really, really, really tiny decimal also. If you multiplied this by 10 to the 6th, 10 to the 6th is 1 million. You would get basically 7.72 million. Okay, so that's obviously not the right answer. So when you're going from the original number to scientific notation, if you move the decimal point to the left, you're going to have a positive exponent, and if you move the decimal point to the right, you're going to have a negative exponent. But remember, you can sort of rationalize why each direction is correct. Now let's take a look at some more examples, some that are going to require a lot more movement of decimals. All right, so we're going to convert this huge number into scientific notation. Now, you look at this number, there's a bunch of commas obviously, but there's no visible decimal point. Whenever you have a number like this that's a whole number that does not have a decimal point, you assume the decimal point is right here at the very end. Okay? So this is a number far greater than 1, so we're going to have to move this decimal point to the left in order to get it right after the initial non-zero number, which is a 6. So let's move it over. 1, 2, 3. Now if you recognize every comma separates 3 numbers, we can go 3, 6, 9, 12, 15, 18, 21, and then 22 and 23. So when I move these decimal points over, I'm going to get 6.022, and then I move the decimal point 23 places over to the left, and so that's going to be times 10 to the 23rd. For numbers like this that are extremely large, you may see them written on a calculator as 6.022 large E 23. This means times 10 to the 23rd. Okay, so hopefully that makes sense. Now let's take a look at this number. This number is far less than 1. In this case, we're obviously going to have to move the decimal point to the right and ultimately put it after this 1, since that's our first non-zero digit. Let's count the number of places over. 1, 2, 3, 6, 9, 12, 15, 18, 21, 22, 23. Okay? And so all I'm left with is 1994, so it's going to be 1.994 times 10 to the minus 23rd power. And again, when you enter this on a calculator, you'll probably see something like 1.994 big E minus 23. Again, that's times 10 to the minus 23rd power. So these are some more examples of how we convert a regular number like this, which is also called decimal notation, into scientific notation. Now let's talk about briefly going the reverse direction. What if you're given scientific notation and you have to convert it back to what we call decimal notation? So these original numbers are called decimal notation. So you might have a question that reads, convert this number, as in scientific notation, into decimal notation. So you then go the opposite direction, right? So if I'm given 5.68760 times 10 to the second, to convert it to decimal notation, all I'm going to do is I'm going to take this decimal and I'm just going to move it 2 places to the right. Okay? And that gets me right back to this number, 568.760. Okay. Now, when you're doing that, another way you could very easily do this if you have a calculator is just type this into your calculator. And it should be able to spit back this number, okay, 568.760. But also remember, since we're taking 5.68760 and multiplying by 10 to the second, which is 100, I should end up with a larger number. And so it wouldn't make sense to move the decimal point to the left at all, because I would get a smaller number. Now in the second example, if we start with 7.72 times 10 to the minus 6th, I now, to get back to the original number, have to move the decimal point over to the left. And so the easiest way to do this problem is to write 7.72 out to the side and just move this decimal point over 6 places and write out these little arrows. So I'm going to move it over 1, 2, 3, 4, 5, and 6. And the last arrow, that will just be where my decimal point goes. Okay? And then in every one of these little humps right here, these little valleys, I guess you could say, you're going to go ahead and put a 0. Just like that. Okay? And you can even put a 0 out in front here. And so my final number will end up reading, after I remove this decimal point right here, it will read 0.0000772, which again is exactly what we had in the beginning. We had 5 zeros between the 7 and the decimal point. So this was how you convert between scientific notation and decimal notation. And just remember, when you're doing this, make sure your final answer makes sense. Remember, if you end up at the end with a 10 to the second or 10 to the third or 10 to the fourth, a positive power of 10, it needs to represent a larger number, much greater than 1. Whereas if you have a 10 to the minus second or 10 to the minus third or even 10 to the minus sixth, it needs to represent a much smaller number, normally a lot less than 1. Please make sure to like this video and subscribe to my channel for future videos and notifications.